Hello class, welcome to lesson 45, the first lesson in Unit 7, Solutions. In this lesson, we will be using reference table F. So if you don't already have it out, take out your Regents Chemistry reference table. We're going to use it a lot today. We're going to use reference table F to determine if a substance is soluble or insoluble. When a substance is insoluble, it is said to form a precipitate. Then we're going to complete double replacement reactions to determine if the product is soluble or insoluble, again using reference table F. So make sure you have reference table F and you're taking notes. If you want, you can download guided notes on Google Classroom. Let's get started. A solution is a homogeneous mixture. Recall that mixtures occur when two or more substances are physically combined. Because the substances are physically combined, they maintain their properties. So here we're going to make the homogeneous mixture of salt and water. Salt is said to be the solute because the solute is the substance that is dissolved. And water is said to be the solvent. That's the substance that the solute is dissolved in. But when you have a homogeneous mixture of sodium chloride, it is still both salty from the sodium chloride and wet from the water. No new bonds, no new properties.
In a homogeneous mixture, it is important to recall that the solute is completely dissolved in the solvent and it cannot be filtered. You'll have to use other physical separation techniques such as evaporation or distillation to separate the components of a homogeneous mixture. Notice here how the homogeneous mixture of salt water is not separated by the filter. Only solid substances or insoluble substances can be separated using filtration.
Recall that when ionic substances are dissolved in water, they will dissociate or break apart into ions. These ions will be free-moving and allow the substance to conduct electricity. Take a minute to look here at what occurs when sodium chloride dissolves in water. Watch as the water arranges itself so the white hydrogen atoms are facing out when it surrounds the gray positive sodium ions, and it arranges itself so the white hydrogens are facing in when it surrounds the negative chloride ions. You can take a minute to look at the still picture on the left, but it is important that you are able to draw the correct orientation of water as it surrounds ions in the dissolving process. Now, molecular or covalent substances will dissolve in water if they are polar like water, but because they do not form ions as they are dissolving, they will not conduct electricity. So here's a nice summary. You can see that an ionic substance in water will form an electrolyte and it will conduct electricity, but a molecular substance in water will not form free-flowing ions, so it will be a non-electrolyte and it will not conduct electricity in water. Remember, water is covalent and does not conduct electricity. Now, solubility is a physical property described as the ability to dissolve. A soluble substance dissolves well, while an insoluble substance will stay solid. Reference table F gives us solubility guidelines. If a substance is soluble, then its formula will be followed by the symbol AQ. If a substance is insoluble, then its formula will be followed by the subscript S to show that it is a solid precipitate. Now, if an exception is met, then the solubility rule is reversed. Soluble substances that meet an exception are insoluble, and insoluble substances that meet an exception are soluble. To determine if a substance is an insoluble precipitate, first look up the anion or the negative ion, and then check for an exception. Let's do an example where we look for silver nitrate. So the negative ion comes last. So nitrate. Here you can see nitrates are soluble. There are no exceptions. So silver nitrate is an aqueous soluble compound. Let's look at this double replacement reaction and determine which product is a precipitate. Let's begin with silver chloride. We'll look for chlorine. Chlorine is a halide. Halides are soluble, except when they are combined with silver, lead, and mercury. So silver chloride is an insoluble precipitate, so we will follow its formula with a subscript S. Now, lead nitrate contains nitrate, which is soluble without exception. Since it is soluble, its formula will be preceded by the subscript AQ. Let's look at this different double replacement reaction where the products include lead bromide and sodium nitrate. Again, we have a halide or a halogen, bromine. These are soluble except with silver, lead, or mercury. So lead bromide is an insoluble precipitate. We'll follow its formula by an S. And sodium nitrate contains nitrate, which is soluble without exception. So we'll follow its formula with an AQ. So by now you should be able to use reference table F to determine if a substance is soluble or insoluble. Now let's look at double replacement reactions. Double replacement reactions occur when two aqueous compounds are mixed together and the reactants switch partners. One product must form a precipitate or an insoluble solid for the reaction to take place. Otherwise, no reaction will occur. Table F will tell you if the products are soluble or insoluble. So when you complete a double replacement reaction, the first thing you want to do is write down the ions of the reactants. Have the positive ions switch partners. Look up the charges of each ion in the new product and determine subscripts so that the new compounds have a total charge of 0. Notice here we have broken up the reactants into sodium and chlorine and silver and nitrate. Then we've switched partners. Now, since the ions have equal but opposite charge, no additional subscripts are needed. The final step, of course, is to use reference table F to determine if a product forms a precipitate. Let's see if we can work through this example. The first thing we'll want to do is break the reactants into ions. So here we have silver chloride and sodium sulfate. Now the reactants will switch partners. So the silver will combine with the sulfate, and the sodium will combine with the chloride. Now we need to make sure that the total charge is 0. Since silver has a +1 charge and sulfate has a -2 charge, I need another silver to make sure the total charge is 0. So I'll add a subscript of 2. Sodium chloride have equal but opposite charges, so no additional subscripts are needed. The final step is to look for a precipitate on reference table F. So I'm going to look at the anion in each of the products. I'm going to start with sulfate. Sulfates are generally soluble, except when combined with silver. So silver sulfate is an insoluble precipitate, so we'll put a subscript of S after its formula. Sodium chloride is soluble, so we'll put a subscript of AQ after its formula. Let's do one final example. Here, the first step will be to break the reactants into ions. So we'll have calcium and bromine and magnesium and carbonate. We do not need to write down subscripts when we break the reactants into their individual ions. Now the ions will switch partners. So calcium will partner with carbonate and magnesium will partner with bromide. Next, we'll check that the total charge of each combination is 0. Calcium carbonate has a total charge of 0 with no additional subscripts, but magnesium bromide is going to need to have a subscript of 2 on the bromine to make its total charge 0. Now let's look at reference table F. We will start with carbonate. Carbonates are generally insoluble, except with group 1. Calcium is not group 1 or ammonium. So calcium carbonate is a solid insoluble precipitate. Magnesium bromide is soluble because it contains the halide bromine. Pause the video and see if you can complete this double replacement reaction and determine the insoluble product. Now let's check your work. First, you divide the ions, then you switch the partners, next you'll need to make the total charge 0 by adding subscripts. Notice that since I'm going to need 3 nitrates, I'm going to have to put nitrate in parentheses and put the 3 outside. Finally, use reference table F. So phosphates are generally insoluble, except when combined with group 1. Sodium is group 1. So that makes this aqueous. Nitrates are soluble with no exceptions, so aluminum nitrate is also aqueous. This reaction will not occur because no solid precipitate is formed. By now, you should be able to complete a double replacement reaction and determine if the product is soluble or insoluble. This concludes lesson number 45. Make sure you've taken good notes. Write down any questions you have and bring them to class. We will discuss them. Complete your homework on Google Classroom and put your reference table and calculator back in your backpack so you are prepared for class. I'll see you soon.